Section 3.1, new chapter here, is about polynomials. The first thing we need to be able to do is classify them a couple different ways. Classify them by the degree. Now, that of course means you need to understand what a degree is, but we'll also be classifying by the number of terms. And then of course we're going to be doing things like adding, subtracting, and multiplying polynomials together. What happens when you combine these things? What do you end up with? Before we get to that, a couple terms to know. Monomial. Mono means one term, right? Or one. And a monomial would be one term. Now that term could be a real number like 2. That's a real number. That can be considered a monomial. Now, a variable, it could be just plain old x. Or it could be a product of real numbers and real variables, such as 2x. Those three things are each considered a monomial. Now, they can have different powers. Now, what separates them and creates a polynomial or many terms? Well, what separates them is addition and subtraction. Okay? So when you start seeing things like addition and subtraction separating them, you can see the separation of the terms. Now, anything that is just a plain old number at the end, when we put things in what we call standard form, remember standard form, like just for what we talked about in for quadratics, a standard form polynomial, that's decreasing order of exponents. Excuse me. There is such a thing as something called the leading term. The leading term is the one that has the highest exponent. I'll just abbreviate it EXP. That leading term has a number in front of it. That's what we call the leading coefficient. Whatever the number is at the beginning of that term, that's the number that we call the leading coefficient. Well, if your constant term has an exponent, truthfully, folks, that's the same thing as writing 5x to the 0, because we know that x to the 0, anything to the 0 power is 1, so that's really like saying 5 times 1. So, as you build your exponent, right, and you go to the next one up, that's x to the first. You know that if we don't write it, then the exponent is a 1. That's what we call the linear term. When we go up to the next one, that's what we call the quadratic term. When we go up to the next one, we call it cubic term. What we're talking about, what I'm listing out, are terms, terminology that describe based upon the exponent. Okay? So we have, that's how we talk about, well, I guess I should have written that over here. Okay. Didn't pay attention, evidently. So, what is a degree? Degree is the highest power of the variable. Remember, we just talked about how this would be the same thing as x to the 0, because that's really 10 times 1, which is 10. So this is a degree 0 polynomial. And the name that we use for that is constant. Number of terms, that's obviously 1. And then the name we use for that is monomial. One term. Next one up, highest exponent is a 1, right? We call that a linear This one, this linear, has two terms, and so we call that a binomial. Prefix bi telling us that there are two terms. This one, the highest exponent right there, is a 2. That's what we would call a quadratic. This particular quadratic has three terms. Remember, you do not have to have, so far the examples that we have all have one more term than they have degree, but that's not always the case, and you know that because you've seen quadratics that only have two terms. So this would be a quadratic, but since there are three terms, we use the term trinomial. Okay? These prefixes, mono, bi, and tri, all go with the number of terms. So here we have a third degree. You can see the highest degree. That would be called a cubic. This particular cubic has 1, 2, 3, 4 terms. So we run out of cool names on the far right column, and so we start saying things like polynomial of 4 terms. I know, very, very creative. And you would say polynomial 5 terms, 6 terms, 7 terms, because we run out of those cool names. But we do not run out of cool names for the degree. So for this is a fourth degree. This is called a quartic, like quarter, 4 quarters in a dollar, that kind of thing. And this has one term. I don't see any subtraction and addition separating multiple terms. And so this is a quartic monomial. This just illustrates my point that I was trying to make earlier, that we don't have to have one more term than the degree. Sometimes we do, sometimes we don't. For the last one, we have a degree 5. That also has a cool name, quintic. Whoa, I can't spell. Quintic, quintic. This one has 3 terms, and so it is a trinomial. So you will need to be able to do that. You will need to be able to look at it, look at the degree, tell me whether it's a constant, linear, quadratic, cubic, quartic, or quintic, and based on the number of terms, use something like monomial, binomial, trinomial, or polynomial of, and then list out how many terms there are. We'll go to the next slide. Write each polynomial in standard form. Okay, so they're making me start with this term over here. Obviously, there's only 2 terms. Classify it by degree. Okay, that's linear. And there are 2 terms, so that is a binomial, linear binomial. Right, because our degree was 1, but we had 2 terms. And here we have a cubic, right, because that right there makes it a cubic. Ooh, I should write it in the form they wanted it first. So, ooh, it's not a cubic. Look at that. They tried to trick me. Negative 3x to the 4th plus 1x cubed and a minus 2x squared. Now we see that it is a quartic. And it's a trinomial because there are 3 terms. So quartic goes with the degree, right? 4th degree, and then 1, 2, 3 terms. Here we have negative 6x squared plus 4x plus 7. That is definitely a quadratic. And there are 1, 2, 3 terms, so trinomial. I know some kids get quad on a 4-wheeler mixed up, and they think, well, why doesn't 4th degree go with the term quad, like a 4-wheeler, and that you ride on? And I'm like, I don't know, to be quite honest. But just keep them straight. Quadratic goes with 2, quartic. I think because they mainly wanted it the idea of quarter to go with 4. Okay, so what happens when we start adding these things, subtracting, multiplying, those kind of things? Well, first of all, Just because there are parentheses do not mean multiplication. Sometimes kids look at these things and they're like, oh, I got to FOIL this. And I'm like, well, pay attention and actually look to see if you do have to FOIL. That probably will come up, but don't act like we have to do FOIL for everything. Like for this first one, I'm literally going to, and I am going to do something that, it might seem elementary school like, but I am going to write them underneath each other. So the 5x squared here, I'm going to put underneath the other one. The minus 6x, I'm going to put underneath that one. And the minus 3, I'm going to put underneath that one. And then I'm going to add down the columns. You guys seem to do a much better job of adding when you line them up in vertical columns. If you don't do that, I see lots of mistakes that happen. So I would suggest you do that. I also do not like your subtraction skills. Lots of you make mistakes with subtraction. So I'm going to show you how to change this to addition. Okay, so first I'm going to distribute this negative. When I distribute the negative 1, it changes to addition. We learned a long time ago that adding a positive and subtracting a negative are the same thing. So I want to line things up like that minus 2x squared, right? Minus 1 times 2x squared is going to be minus 2x squared. Put it in the column it belongs in. And then that minus 1 times that minus 3 makes a plus 3. Now, add down the columns, right? There's nothing to add to that one, so it's 6x to the 4th. And then in the middle, we have 2x squared. And then at the end, we have a plus 2. So, just line things up. Distributing the negative 1 changes to addition. I promise you, you will do much better if you follow that instruction. And those of you who ignore it will probably make mistakes. So for instance here, before I do much further, I'm going to have to multiply. I got 15x squared plus 20x minus 10. Now I'm going to distribute this, negative 12x plus 10. And now I know I can change this to addition, but because I distributed the negative 2. And so I get 15x squared plus 8x. And then the 10s at the end cancel out. So there's my answer to that question. Just simplifying these things, changing it from subtraction to addition. I think that's it for this slide. Yep. Okay, so now we're into the multiplying and classifying. Did I have to classify on the last one? So obviously I didn't read all the instructions, right? I did all the right work, but then I didn't do the rest of it. So let's classify this. So the first one is a quadratic binomial, because there's 2 terms. And state the leading coefficient. I'm just going to abbreviate leading coefficient with LC. Hopefully that makes sense. So my leading coefficient here is 13. Next one over. Okay, so this is a quartic trinomial. And leading coefficient 6. And the last one is a quadratic binomial. Leading coefficient 15. Sorry I didn't do that earlier. Now we can go to the next slide. So I'm a big fan of using the box method, although if you simply want to draw arrows like this, if that's your favorite method of doing this, I am not opposed to that. So if you want to match things up that way, now if I were doing that, I would make sure that I line things up vertically. But for those of you who want to use the box method, which it's not a bad idea just because you sometimes we have a tendency to lose things. Put one of the polynomials on one side and the other one on the other side, and then simply match things up. For instance, x times x squared is x cubed. X times negative 3x is negative 3x squared. X times 11 is 11x. In the bottom left, I have 3x squared. And then I have minus 9x. And then lastly, 33. For those of you who would be doing it kind of the way I drew with the arrows at the beginning, you would have your x cubed, you would have your minus 3x squared, and then your positive 11x. When you go to the next part, you would put your 3x squared here, your minus 9x here, and then your positive 33 would be in its own column because it's separate. Now, if you would rather do that so that you see them vertically lined up before you switch, right? Because in the box method, you're going to look at that and say, oh, those two cancel up. And these two, so you're going to have x cubed plus 2x plus 33. Well, here you see the exact same thing, x cubed plus 2x plus 33. I do not care which way you do it. Doesn't matter to me. This is a cubic trinomial with leading coefficient equal to, what's that number in front of the x cubed? That's a 1, folks. Anytime you don't see a number written there, we automatically know it's a positive 1. Okay, let's try that next one. Once again, I do not care which method you want to use, so you pick whatever works for you. If you're a box fan because it helps you organize things, then stay with it. And if that box just annoys you a lot and you don't want to use it, then don't. Simply do what I did and draw the arrows. But it is completely up to you how you do this, like 21x cubed, 28x squared, minus 14x, minus 6x squared, minus 8x, and a positive 4. And so then you can add your like terms. 21x cubed. Of course, the 28 take away 6 makes 22x squared. Negative 14 minus 8, that would be negative 22x, and a positive 4 at the end. This is a cubic polynomial of 4 terms. And the leading coefficient of that is a 21. All right, next on my list, last thing is multiplication of these two over here. So, same scenario, different question. 2x minus 1, 4x squared. Do your favorite method. Whether you want to draw the arrows or do a box, it is completely up to you. Nobody's going to get mad at you one way or the other. I don't see significant mistakes made in either method. Sometimes people forget things when they don't use a box, but that's completely up to you. And let's see here. Whoa, look at some things canceling out here. Wow. So we are down to 8x cubed minus 1. So we have a cubic binomial, because there's two terms, with a leading coefficient of 8. And there you go on these notes. See you next time.